Operation Epic Fury cost $11 billion in the first 6 days. Not because American weapons are expensive, but because the United States military-industrial base was never built to sustain what the Navy just demanded of it. For 6 weeks, the American Navy burned through ammunition at rates that the defense industrial base cannot replace. Tomahawk missiles that take 9 months to rebuild. Ship maintenance backlogs measured in years. A workforce that's smaller than it's been in a generation. This is not a strategy problem. This is a manufacturing problem. And it's about to define the future of American naval power. When the Pentagon told Congress that Operation Epic Fury cost $11.3 billion in the first 6 days, they were being precise about money and vague about what that money actually bought. Let's translate that into what actually happened. Tomahawk Block 5 missiles, $1.5 to $2 million each. Raytheon's production rate, 500 per year. That's roughly 1 week's worth of sustained operations. SM-6 air defense missiles, 2 to 4 million each. Current production constrained by the same industrial base, bottleneck. A PKWS guided rockets, $35,000 per shot. Used by the hundreds across the campaign because they're the only rapid production option for certain target sets. And these are just the headline systems. Add in the unguided ordnance, the aviation fuel consumed by 3 carrier strike groups at thousands of gallons per aircraft per sortie, the logistics overhead, and the constant replacement of systems damaged or expended in combat. The $11.3 billion figure omits all of that. It's the weapons-only cost, and it's already impossible to sustain. The Department of Defense has asked the American Munitions industrial base to do something it was not built to do. Replenish a war inventory while simultaneously building inventory for a conflict that hasn't happened yet. The industrial base said no, not explicitly, but through schedule slips, production rate constraints, and the simple reality that the factories that make these weapons run at capacity that was determined a decade ago for peacetime procurement. The United States has 4 naval shipyards that are authorized to perform maintenance on nuclear-powered submarines and carriers. 4, they're located in Norfolk, Virginia, Groton, Connecticut, Bangor, Washington, and San Diego, California. And they're all full. The Virginia-class submarine that should be on patrol in the Pacific is in the shipyard. The carrier in maintenance is not available for strike. The destroyer awaiting overhaul is not covering the Taiwan approaches. That's not a tactical problem, that's a measurement of industrial capacity, and we're exceeding it. The Navy's own analysis shows that the maintenance backlog at these 4 facilities has grown by 37% since 2020. Every ship that sits in overhaul longer than planned is a ship that's not available for the strategic competition with China. And the strategic competition with China is what the entire force structure is supposed to be built for. The Navy has been operating for years at an operational tempo that was already consuming its forces faster than they could be maintained. Epic Fury didn't create that problem. It made it impossible to ignore. The Navy needs 66 Virginia-class submarines by 2043. That's the operational force structure requirement established by the Navy's strategic planning process. The Navy is currently building approximately 1.1 to 1.2 boats per year. Electric Boat and Huntington Ingalls manufacture these submarines. They're the only 2 shipyards in America capable of building nuclear attack submarines. The Navy says they can increase production to 2 boats per year beginning no later than 2028. That requires sustained industrial investment, workforce training, supply chain expansion, and the kind of multi-year budget commitment that Congress has demonstrated it's unwilling to provide consistently. At the current production rate, the attack submarine force will decline from its current level of approximately 50 boats before the production rate can increase sufficiently to reverse the trend. That gap is not theoretical. Every boat that doesn't exist is a boat that isn't patrolling. Every patrol that doesn't happen is a gap in the intelligence picture that supports deterrence. The Navy can brief Congress on the force structure requirement. What it cannot do is magic submarines into existence on a faster timeline than the industrial base allows. Let's talk about what happened to the Tomahawk inventory. Before Operation Epic Fury, the United States military had what was considered an adequate cruise missile inventory. Not abundant. Adequate. The kinds of numbers that support operations on the scale that the military has become accustomed to conducting. Operation Epic Fury consumed that inventory in ways that have no clear replenishment timeline. Raytheon, the primary Tomahawk manufacturer, has been operating at full production capacity. The Block 5 production rate is 500 missiles per year. The Pentagon has requested increased production. Raytheon says they can add capacity, but it will take time. Plant expansion, workforce hiring, supply chain management. The estimate is that a meaningful increase in Tomahawk production won't materialize until 2027 or 2028. Against a campaign that consumed hundreds of missiles in the first few weeks, the math is simple. The existing Tomahawk inventory will not be restored to pre-Epic Fury levels until the early 2030s. That's a strategic constraint that has no military solution. You cannot make policy based on the weapons you want to have. You make policy based on the weapons you actually possess. And for the next 5 to 7 years, the Tomahawk inventory constraint is real. The Navy's answer to the munitions problem is directed energy and autonomous systems. During Operation Epic Fury, destroyers equipped with Odin and Helios laser systems engaged drone threats at a cost measured in electricity. The marginal cost of engaging a target with a directed energy weapon is in the hundreds of dollars. The same engagement with an SM-6 missile costs $4 million. APKWS, guided rockets fired from helicopters, and fixed-wing aircraft engage threats at $35,000 per shot. The economic logic is straightforward. The Navy got operational validation that directed energy systems work against real threats in a contested environment. That validation is now driving acquisition decisions. The fiscal year 2026 budget includes $7 billion for unmanned systems investment. $3.7 billion is going to the surface force. This is not experimental funding. This is operational procurement being executed in response to what happened in the first weeks of Epic Fury. Small unmanned surface vessels that cost $50,000 to $80,000 to build are being procured by the hundreds to extend the sensor reach and weapons capacity of manned ships without requiring proportional increases in crew. The Navy went into Epic Fury expecting to fight with Tomahawks and SM-6. It came out understanding that the future fight will be fought with drones and directed energy and whatever precision munitions the industrial base can actually replace on a timeline that matches operational demand. That's not strategy change. That's adaptation to industrial reality. China has approximately 370 naval vessels. The United States has approximately 294. China is building faster. The Chinese shipbuilding industrial base is larger, more flexible, and operates under a centralized planning regime that does not require congressional approval for every increase in production capacity. The comparison is not apples to apples. The United States Navy operates globally. Chinese naval forces are concentrated in the Western Pacific. American ships are more capable per hull. Chinese ships are built in larger numbers at lower unit cost. But the asymmetry is real and it's structural. The United States has 3 private shipyards capable of building Navy combat vessels: Bath Iron Works in Maine, Huntington Ingalls in Mississippi, and General Dynamics in San Diego. China has multiple state-owned shipyards operating at higher production tempos and with the ability to surge production in ways that the American commercial shipbuilding industry cannot match. The American shipbuilding industrial base was hollowed out over the post-Cold War decades. Companies consolidated, yards closed. The remaining yards operate at near capacity on existing Navy contracts. When the Navy asked for increased ship production, the yards said, build more facilities, hire more workers, provide sustained multi-year contracts. The Navy said, we have budget constraints and congressional approval processes. That conversation has not been resolved. The consequence is that China is building a larger fleet faster, while the United States is constrained by the physical capacity of 4 or 5 shipyards that operate at near saturation on existing contracts. The American defense industrial workforce is aging. The average age of a skilled shipyard worker is over 50. The apprenticeship pipeline that's supposed to replace retiring workers has been underfunded for years. The aerospace and defense industry is competing with commercial tech for skilled manufacturing talent. A welder at a shipyard makes a respectable living. A software engineer at a tech startup makes significantly more. The result is a workforce shortage that is structural and not easily fixed in the short term. China does not face this constraint to the same degree. The Chinese government can direct labor towards strategic priorities. The American private sector cannot. The Defense Department has launched initiatives to attract young workers to shipyard careers. Tax incentives, workforce development programs, apprenticeship funding, these are necessary. They're not sufficient. Building the industrial capacity required to match China's shipbuilding tempo would require attracting and retaining tens of thousands of skilled workers in geographic regions where the cost of living has risen sharply and where commercial alternatives offer better compensation. That's not a defense problem. That's an economy-wide structural challenge. The United States spends more on defense than China, approximately $820 billion versus an estimated $300 to $400 billion, depending on how you account for purchasing power and hidden military spending. But the American defense budget has to fund global operations, naval bases in Japan, Germany, Italy, the Middle East, air operations supporting NATO, Army presence in Europe, the strategic nuclear deterrent. China's military budget is concentrated on developing capabilities relevant to Western Pacific conflict. Naval forces, air forces, anti-ship missiles, and defensive air systems oriented toward the scenarios China cares most about. The American defense budget is spread across global requirements. The Chinese military budget is concentrated. For naval ship construction, the effective budget available for new construction competes against maintenance of the existing fleet, crew salaries, and operations. The Navy does not get to claim the entire defense budget for ships. The Chinese naval budget has to fund all the same things, but the Chinese government has demonstrated a willingness to accept deferred maintenance and reduced readiness in other areas to prioritize naval shipbuilding. The American political system has not made that choice. Congress funds Navy maintenance, congressional districts demand Navy spending that's spread across the country, and the result is that the Navy ship construction budget is constrained by the same budget pressures that constrain every military service. That's not a strategy problem, that's a political economy problem. And it explains why China can sustain a higher shipbuilding tempo while the American Navy is constrained. There is a school of thought in defense planning that says if we really needed to, the American industrial base could mobilize to produce weapons at Cold War or World War II rates. That's not wrong exactly. It's not right either. It's incomplete. The American industrial base could theoretically expand munitions production if the government provided the capital investment, the workforce training, the supply chain support, and the sustained political commitment to bear the peacetime cost of maintaining surge capacity. But we don't do that. We shut down surge capacity after wars. We allow industrial skills to atrophy. We consolidate production into fewer, larger facilities that are more efficient in peacetime but less flexible in crisis. If the United States faced a major conflict with China tomorrow, the American military would fight with the inventory of weapons it already possesses, plus whatever can be produced in the first months of conflict using existing capacity. The Tomahawk inventory constraint is real. The submarine production constraint is real. The maintenance backlog at naval shipyards is real. You cannot mobilize your way out of a constraint that exists in peacetime. You can only address it by making different choices about what you build, how you build it, and how much of the budget you commit to industrial surge capacity that sits idle in times of peace. The Navy's answer to the industrial constraint is the Drone Dominance Initiative. It's not really a strategy change. It's an acknowledgement that the industrial base cannot produce enough expensive, capable, slow to manufacture weapons to support the operational demands that the Navy faces. The alternative is to produce large numbers of cheaper, faster-to-manufacture systems that can be built in shorter timelines and at volumes that the American industrial base can actually support. A loitering drone costs $35,000 to $40,000. It's not cheaper than a Tomahawk in absolute terms. It's cheaper per target destroyed against the categories of targets it can efficiently engage. And it can be produced in quantities that are orders of magnitude larger than precision cruise missiles. The Pentagon's call to industry for 300,000 to 340,000 small drones over approximately 2 years with unit cost targets in the low thousands of dollars is not a futuristic aspiration. It is procurement happening right now. That call to industry was made in response to the operational realities of sustained combat operations against a country that was actively trying to kill American sailors. It is the industrial base's answer to the question, what can we actually manufacture at volumes that match operational demand? The Constellation-class frigate is scheduled to enter service in 2028 or 2029. The Navy plans to build 20 of them. It's a new surface combatant design, the first new frigate class since the Oliver Hazard Perry class in the 1980s. The Constellation class is significantly less expensive per hull than an Arleigh Burke destroyer. It cannot match the destroyer's capability against advanced threats. It's designed for lower threat missions that currently consume destroyer deployments. The Navy's motivation is straightforward. The Arleigh Burke destroyer costs approximately $2 billion per hull. The Constellation class is designed to cost significantly less. If the Navy had unlimited budget, it would build all Arleigh Burke destroyers. Destroyers are more capable, but the Navy's budget is not unlimited. The surface combatant force is smaller than strategic requirements demand. The Constellation class is the Navy's way of increasing hull count without the budget impact of building only expensive destroyers. But the Constellation class faces its own industrial constraints. General Dynamics, the lead contractor, has experienced schedule delays. The production timeline has slipped. The Navy's target of 20 ships could take until 2040 to complete. That's not an acceptable timeline for a force structure requirement that is needed now. The industrial base is constrained. The solution is cheaper ships. But cheaper ships face their own production constraints. That's the cycle the Navy is trapped in. Requirements exceed resources, so they design cheaper alternatives, but the cheaper alternatives face production constraints that limit even their availability. The Navy that fights in 2035 will be defined by the industrial choices being made right now. It will have more unmanned systems than it has today, fewer large surface combatants than strategic requirements demand, fewer submarine patrols than the Western Pacific needs, and a maintenance backlog that remains unsolved because the shipyard capacity to solve it doesn't exist. It will be more innovative, more reliant on technology to compensate for smaller numbers, and potentially less capable than the Navy that the strategic analysis says it needs to be. The question is not whether the industrial base is the constraint. The operational data from Epic Fury has made that clear. The question is whether the Congress, the administration, and the American public understand that constraint clearly enough to make the choices required to address it. Those choices are expensive. They require sustained investment in industrial capacity that will sit partially idle in peacetime. They require making hard decisions about what the Navy actually is and what it actually can do with the forces and the industrial base the country provides. Epic Fury cost $11 billion in the first 6 days. The real cost is going to be measured in the decisions about what we build, how much we build it, and how much of the American economy we're willing to dedicate to sustaining naval power in a strategic environment that's not going to wait for us to get our industrial base sorted out. The Navy has always found a way. The question now is whether it will find a way when the constraint is not strategy or doctrine or boldness, but the simple, hard reality of industrial capacity. If you want to follow every development in the Navy's post-Epic Fury industrial modernization, the production milestones, the capacity decisions, the workforce challenges being confronted, and the industrial trajectory that will define American naval power in 2035, subscribe to Naval Power Decoded. The next chapter of American sea power is being written in the factories. Let's understand what's being decided.